Hello everyone. Previous lecture we have studied the concept related with the chapter pair of straight lines, and in that we see the second degree homogeneous equation. That is the concept related with the homogeneous equation of second degree in x and y. In that we see here ax square plus 2hxy plus by square is equal to 0, and this is the second degree homogeneous equation in x and y. Then we study the two important theorems. In that, first is the combined equation of pair of lines passing through the origin is always in the form of here ax square plus 2hxy plus by square is equal to 0. And in second theorem, we see the second degree homogeneous equation in x and y, that is here ax square plus 2hxy plus by square is equal to 0. This equation represents the pair of lines passing through the origin. Okay, so these two theorems are very important. Now in today's lecture we go with our next concept in this chapter, and in that we consider sum and product of the slopes. Sum and product of the slopes. Here to define this concept, again we consider the second degree homogeneous equation. Okay, here consider equation is here ax square plus 2hxy plus by square is equal to 0. And in that, here a, h and b are all constants and not all 0. Okay, here to define this sum and product of the slopes, firstly we have to consider the slopes of the given lines. Okay, let us consider m be the slope of one of the line represented by this equation. Okay, so here I write let m be the slope of one line represented by given equation. Given equation means our equation ax square plus 2hxy plus by square is equal to 0. Okay, let us consider this as 1 first. Then here we get here m, we know here m is the slope of one of the line, so its equation is, okay, here its equation is y is equal to mx. Since our lines passing through the origin, here we consider y is equal to mx is the equation. Let us consider this as 2. Now we have to solve these two equations, first and second equation for the slopes. Okay, so solving 1 and 2 for slopes, here we get, okay, now we replace here y is equal to mx in the first equation. If we replace here, we get ax square plus then 2hx into y. We know y is mx, so we replace by using mx, then plus b into y square means mx, this bracket square is equal to 0. Okay, now in next step we consider here ax square as it is, then plus here we get 2hm into x square. Okay, here x into x is x square, then in last here plus b as it is, then we know this mx bracket square is here m square x square and is equal to 0. Okay, now we consider, or we take x square as common, so here we get x square into bracket a plus twice hm plus bm square is equal to 0. Let's divide both the sides by x square. If we divide here, we get bm square plus twice hm plus a and is equal to 0. We get this quadratic equation. We get this quadratic equation, and this is quadratic equation in M. This is quadratic equation in M, and it has two roots. Let us consider M1 and M2 be the given two roots. Okay, let here M1 and M2 be the roots of given quadratic equation. Okay, and here these roots M1 and M2 represents the slope of the line represented by the equation here ax square plus 2hxy plus by square is equal to 0. Okay, here M1 and M2 represents the slopes of lines represented by ax square plus 2hxy plus by square is equal to 0. And here remember, here m1 or here bm square plus twice hm plus a is equal to 0 is the auxiliary equation. It's called the auxiliary equation of the given homogeneous equation. Remember this. Okay, now here we get m1 and m2 be the slopes of the given lines represented by the given equation. Okay, now we have to consider sum and product of these slopes, and here after solving the given equation we get here m1 plus m2 is equal to minus twice h upon b, and here m1 m2 is equal to a upon b, and here b is not equal to 0. So here we have to remember m1 plus m2 is twice h upon b, and here m1 m2 is equal to a upon b. So here we consider sum of the slopes and we consider product of the slopes. Here sum of the slopes is minus twice h upon b, and product of the slopes is here a upon b. Okay, so by using this concept, we have to solve some examples. Okay, so we go with our examples. Example, first we consider find the combined equation of the pair of lines. Find the combined equation of pair of lines passing through origin and perpendicular to the lines represented by the equation. Your equation is having 5x square minus 8xy then plus 3y square is equal to 0. Okay, here in this example, we have to find the combined equation, okay, of the pair of lines. And here given our pair of lines perpendicular to the lines represented by this equation, represented by the given equation. Okay, so by using our concept of sum and product of the slopes, we have to find the combined equation. Okay, so here we consider given equation again. Given equation is here is a 5x square minus 8xy plus 3y square is equal to 0. Here we know this equation is in the form here ax square plus 2hxy plus by square is equal to 0. So we compare our this given equation with our second degree homogeneous equation. So comparing this equation with here ax square plus 2hxy plus by square is equal to 0. Here we get. Now we compare these two equations. Okay, here in the position of a we have 5, so here a is equal to 5. Then here in the position of 2h we have minus 8, so 2h is equal to minus 8. Then here in the position of b we have 3, so here b is equal to 3. Now we know here a, 2h and b, we know this. Okay, now we consider the slopes of the given lines, slope of the lines represented by this equation. Okay, let m1 and m2 be the slopes of lines represented by equation. Given equation is 5x square minus 8xy plus 3y square is equal to 0. Now we know here slopes. Let us consider some of the slopes and product of the slopes. Okay, therefore here m1 plus m2, we know m1 plus m2 is minus twice h upon b. So here minus twice h upon b equal to, here with minus sign we know 2h is minus 8, so we replace 2h by using minus 8. Then this divided by b, here we know b is 3 and this is equal to 8 by 3. And we consider product of the slopes, that is here m1 m2, we know here m1 m2 is a upon b. Okay, so here a upon b is equal to, we know a is 5. Okay, so here 5 by 3 is the product of the slopes. Okay, so here we know m1 plus m2 and m1 m2. Here also given our required lines, required pair of lines perpendicular to the lines represented by this equation. Okay, so we consider also given required pair of lines are perpendicular to the lines represented by here given equation, that is 5x square minus 8xy plus 3y square is equal to 0. Since required lines are perpendicular to the given pair of lines represented by given equation, here we get slope of the required lines. Here we get slope of required lines. Okay, so here I write, therefore the slopes of required lines are, okay, since our first line is perpendicular to the line represented by this equation, here we get slope -1 upon m1, and here second line is perpendicular to the line represented by this equation, so here we get -1 upon m2, okay, respectively. Okay, so here we know the slopes. Let's find the equation of required lines. Therefore the equations are here for first line we consider y is equal to, we know slope of first line is -1 upon m1 into x. Okay, so here we get m1y is equal to minus x. Okay, so here we get x plus m1y is equal to 0. This is for first line. Now we go with our second line. Here y is equal to, slope of second line is -1 upon m2 into x. Okay, therefore here I write m2y is equal to minus x. Then here we get x plus m2y is equal to 0. So we get here our required lines. Here x plus m1y is equal to 0 is the first one, x plus m2y is equal to 0 is the second one. Let's find the combined equation. Since we have to find the combined equation, here we consider combined equation of these two lines. Therefore the combined equation is okay, here u is first one, v is second one, so its equation is here x plus m1y into x plus m2y is equal to 0. Okay, let us consider product of these two. Here we get, let's multiply the second bracket by x first. If we multiply, we get x into bracket x plus m1y. Okay, then we multiply the second bracket by m1y. Here m1y into x plus m2y and is equal to 0. Then we multiply this bracket by x. If we multiply, we get here x square plus m1xy plus, then we multiply the second bracket by m1y. We get here m1xy. Okay, here we get m1, sorry, here we consider one change. Here second bracket is having m2. Okay, so here we get m2xy. Okay, next here now we multiply this bracket by m1y. We get m1xy plus here we get m1 m2 into xy square is equal to 0. Okay, so we get this form. Now from the second and third term, we consider xy as common. Okay, so here in next step, here in first x square plus m1 plus m2 into xy plus in last we have here m1 m2 y square. m1 m2 y square is equal to 0. Now here we know m1 plus m2. Here m1 plus m2 is 8 upon 3. Then we know m1 m2. Here m1 m2 is 5 upon 3. So we replace here m1 plus m2 by using 8 upon 3 into xy plus m1 m2 by using 5 upon 3, and this is equal to 5 upon 3 y square is equal to 0. And in last here we get 3x square plus 8xy plus 5y square is equal to 0, and this is the required combined equation. Okay, this is required combined equation. Okay, so we get this combined equation. Very simple example it is. Let's go with second example. Here in second example, we consider find k if the sum of slopes of the lines represented by equation here x square plus kxy minus 3y square is equal to 0 is twice their product. Okay, so by using the given conditions, we have to find the value of k. Again, by using the sum and product of the slopes, we have to find value of k. Okay, let us consider given equation. Consider here given equation is having x square plus 5xy minus 3y square is equal to 0 is the given equation. Sorry, here in this example we have a k. Okay, we replace 5 by using k. Here given equation is having x square plus kxy minus 3y square is equal to 0. We consider same equation. Okay, now here we compare this equation with ax square plus 2hxy plus by square is equal to 0. Comparing this equation with here ax square plus 2hxy plus by square is equal to 0. Here we get okay, here in the position of a we have 1, so a is equal to 1. Then here in the position of 2h we have k, so twice h is equal to k. Then here in the position of b we have minus 3. Here we have minus 3. So we know a, 2h and b. Now we consider sum and product of these slopes. Okay, so here I write therefore m1 plus m2. Okay, now here we consider m1 and m2 be the slopes of the given lines. Slope of the lines represented by the given equations. Okay, so here m1 plus m2 is equal to minus twice h upon b is equal to minus. Here twice h is k, so k upon b is minus 3, so we get here k upon 3 only. Then we consider product of the slopes, that is m1 m2 is equal to a upon b. We know a is 1 and b is minus 3. Lastly we get minus 1 upon 3. So we know m1 plus m2 and we know m1 m2. Now our given condition is here sum of the slopes represented by the given equation is twice their product. Okay, so we consider the given condition. Here sum of the slopes, that is m1 m2 is twice their product, means 2 times here m1 m2. This is given. Therefore here m1 plus m2 is k upon 3 equal to here 2 as it is. Then product of the slopes is minus 1 upon 3. Okay, and here we get k is equal to minus 2 into 3 upon 3. And lastly, here we get value of k as -2. Value of k as -2. So by using sum and product of the slopes, we find the value of k and we consider given conditions to find the value of k. Okay, let us consider third example. Here in third, given find k. Again, in this example, we have to find value of k if the slopes of the lines represented by equation. Here equation is having 3x square plus kxy minus y square is equal to 0 is differ by 4. Okay, here we have to find value of k if the slopes of the lines represented by this equation is differ by 4. Okay, again by using the sum and product of the slopes, we have to find value of k. Here we consider our given equation. First, consider here given 3x square plus kxy minus y square is equal to 0. Let's compare this equation with ax square plus 2hxy plus by square is equal to 0. Comparing this equation with ax square plus 2hxy plus by square is equal to 0. Then we get a is equal to 3 twice h is equal to k, b is equal to -1. Let us consider m1 and m2 be the slopes of the given slope of the lines represented by this equation. So here we consider m1 plus m2 and m1 m2. Let m1 and m2 be the slopes of the lines represented by given equation. Okay, so here we find m1 plus m2. We know m1 plus m2 is a minus twice h upon b with minus sign. Here we know twice h is k. Then this divided by b. Here b is -1 and lastly we get k only. And here product of the slopes, that is m1 m2 is equal to, we know this is a upon b. We know a is 3, b is a -1 and lastly we get -3. Okay, now we consider the given condition. Here given the slopes of the given lines differ by 4. These differ by 4. So here I write also given, since slopes differ by 4, here I write m1 minus m2 is equal to 4. That is difference in between m1 and m2 is 4. Okay, now by using this sum and product of the slopes, we have to find value of k. And to find this, firstly here we consider square on both sides. So we here I write here m1 minus m2, this bracket square is equal to 4 square. Okay, then in next step we consider expansion of this bracket. We know m1 minus m2 bracket square is here m1 square minus 2 times m1 m2 plus here in next m2 square is equal to, we know 4 square is 16. Okay, here we consider one adjustment. here I write m1 square plus 2 times m1 m2 plus m2 square minus 4 times m1 m2 is equal to 16. Here I write this minus 2 m1 m2 as here 2 times m1 m2 minus 4 times here m1 m2. Okay, now here we know this bracket. We know this m1 square plus 2 m1 m2 plus m2 square is, here is m1 plus m2, this bracket square, minus 4 into m1 m2 is equal to 16. Now we know here m1 plus m2 is k, so here we get only k square minus 4 into, we know m1 m2 is minus 3, so here minus 3 is equal to 16. Then in next step we consider k square minus, here we know minus 4 into minus 3 is a plus 12 is equal to 16. Okay, next here I write this as k square is equal to 16 minus 12. Okay, in next step we consider k square is equal to 4. Okay, now consider square root on both the sides. We get value of k as here plus minus 2. We get value of k as plus minus 2. Okay, so by using the given condition we find the value of k. Let us consider one more example. Here in fourth we consider if the slopes of one of the lines given by ax square plus 2hxy plus by square is equal to 0 is 4 times the other, then show that given 16h square is equal to 25ab. Okay, again by using the sum and product of the slopes we have to show this relation. Let us consider given equation. Consider here given ax square plus 2hxy plus by square is equal to 0. Let us consider m1 and m2 be the slopes of the lines represented by the given equation. Let here m1 and m2 be the slopes of lines represented by given equation. So here we consider m1 plus m2. Here m1 plus m2 is equal to minus twice h upon b, and we consider m1 m2. Here m1 m2 is equal to a upon b, and here b is not equal to 0. Okay, now we go with our given condition. Here given slope of one of the line is 4 times the other. Okay, so here I write also given. Let us consider m2 is 4 times m1. Okay, m2 is 4 times the m1. Now we consider here sum of the slopes. We know m1 plus m2 is minus twice h upon b. Okay, again here I write consider m1 plus m2 is equal to minus twice h upon b. Okay, here we know m2 is 4m1, so m1 plus 4m1 is equal to minus twice h upon b. We know m1 plus 4m1 is 5, m1 is equal to minus twice h upon b. Then I write here m1 separately as, here m1 is equal to minus twice h upon 5b. Let us consider this as 1. We get m1 as minus twice h upon 5b. Okay, now we consider the product of the slopes. Now we consider the product of the slopes. Okay, consider m1 m2 is equal to a upon b. We know here m2 is 4m1. Okay, so we replace m2 by using 4m1 is equal to a upon b. We know m1 into 4m1 is, here 4m1 square is equal to a upon b. Now we know here m1 is a minus twice h upon 5b. So we replace here m1 by using minus twice h upon 5b and its square is equal to a upon b. Then here I write 4 into, we know minus twice h square is 4h square. This divided by, we know 5b square is a 25b square is equal to a upon b. Next, here we know 4 into 4 is 16. So in numerator we consider 16h square upon 25b square is equal to a upon b. Now here we want in LHS we want 16h square. Here we want 16h square. So I write 16h square separately as a into 25b square upon b. Okay, and in last here we get therefore 16h square is equal to, here 1b from numerator and b from denominator cancel, and here only remains 25ab, and this is we have to show, okay. So in today's lecture we go with our new concept in the chapter pair of straight line and is sum and product of the slopes. We see concept related with the sum and product of the slopes. Then we consider 4 examples related with this concept. Thank you.